In this next section, we are going to explore the measurement of volume. We're pretty familiar in our day-to-day lives of dealing with stuff like mass and weight. Volume is a 3D measurement, though, and it's a little harder to visualize and interpret a volume measurement. So let's take some time and explore this subject. Alrighty, so volume is how much space something occupies. Y'all told me that a few weeks ago. So let's dive in a little more about what that means. The unit we commonly use is the liter, written as capital L for the symbol. Liters are actually not a base unit, so meters or seconds or kilograms, those are our base units, right? The liter is actually another way to think about meters cubed. That's because, think about in geometry class, when you're trying to calculate the volume of a cube, right? So you have the length times the width times the height. Those are all length measurements, right? So that's really meter times a meter times a meter, meter cubed. We like to think of this in terms of liters, though, in chemistry. It's pretty cool, though, that it's based on length. Pretty cool combination of units there. In this class, and in other chemistry classes you may take, a lot of the times we're not working with enough volume to fill up a whole liter, though. Think of like a 2 liter of soda. Like that's a lot of stuff. Instead, we think of smaller portions of the liter. Let's make yet another table. So we have our unit, our symbol, and I want to give the relationship to the base unit. All right. So the unit we're first going to look at is the liter. So this is capital L, and we're going to call this our base unit. This is what we're starting with for comparing other volume measurements. Again, a lot of the times we're not working with enough stuff to make up a full liter. Like that's actually quite a lot. Instead, a common unit we work with is the milliliter. The milli, should be giving off some bells in your head. This is a prefix. We're saying a milliliter. Milliliter. The symbol we use here is little m for milli, big L for liters, and this is the relationship to a liter is that there are 1,000 milliliters in 1 liter. This should make sense because, again, milli is 1/1000th of your unit. So 1,000 of it is 1. There's another unit that we're going to come across, and this is going to look a little confusing at first, okay? The unit is the cubic centimeter. I remember when I first learned about this, it took a while to sink in. A cubic centimeter, the symbol is C for centi, M for meter, but it's cubed, it's cubic, so there's a 3 in the exponent. So So for this, y'all, if you can't remember the math of how this equation holds true, honestly, all you need to do, just know this relationship. 1 cubic centimeter is equal to 1 milliliter. Okay? It has to do again with this box and how we're saying length times width times height. 1 cubic centimeter is equal to 1 milliliter. Again, if you're not comfortable doing kind of the math to get to that spot, just know this. Know this. I want to give you some examples of the relative size of these different units. You don't need to write this down. This is just for, you to help be able to look at these SI units and make a little bit more sense of them. Alrighty, a liter. So you're probably familiar with the 2-liter soda bottles, so split that in half. Also, if you think of a quart, like a quart of milk, that's approximately a liter. 1 milliliter, though, 1/1000th of a liter. 1 milliliter is approximately 20 drops of water. So very tiny, small amount. A cubic centimeter, so remember 1 cubic centimeter is equal to a milliliter. So cubic centimeters, we can think of volume in terms of both for a liquid, for a solid, for a gas, right? We have a certain volume. And so the cubic centimeter is pretty useful for thinking about a lot of solids, for example. So we looked at this, right? Volume is the length, the width, and the height that something takes up in space. So 1 cubic centimeter is equal to 1 milliliter. But if we want to think in terms of solids, 1 cubic centimeter is approximately 1 cube of sugar. When we get into the lab, which we will eventually, we're going to be working with measuring out chemicals. So chemicals could be solid, liquid. Most of the time we're going to be working with solids or liquids. And measuring out solids is pretty straightforward. We can use a balance, a digital balance, and set it on the scale and measure out the mass we need. However, for measuring out a liquid, it's not always as simple as putting it on a scale. When we need to measure out liquids, and a lot of the times we'll be measuring out water, for example, we use graduated cylinders. Let's look at some examples of graduated cylinders and how to take their measurements. Because again, it's not as straightforward as just putting your sample on the balance and getting a digital reading. Again, we measure out liquids using graduated cylinders. You've probably seen these around some of the labs on campus. They are literally glass or plastic, most of the time glass, cylinders, right? Like they're tall cylinders with a base so you can set them on the tabletop. And they have markings along the side. So in this case, the markings are in white, so it's a little bit harder to see, but they have these markings. That's where the word graduated comes in, because they're the graduated measurements along the side. And as we see here, there are a variety of different size graduated cylinders. And in a few minutes, we will actually look at some real ones. I brought some home with me to show y'all some demos with. So before we get into how to measure liquids in a graduated cylinder, I want to take a step back and remind y'all that water has surface tension. And this becomes relevant in how to read a graduated cylinder. So water has surface tension, and that lets stuff like these, is that a stink bug? Gross. It's a buggy bug on the top of the water, and it's not just falling through. It's actually able to glide along the top due to water surface tension. If you think about dewdrops on a leaf, in the morning, very pretty looking, the water doesn't just like explode and fall off the side. It forms these nice little drops due to surface tension. And let's say you're in the kitchen and you're making you're cooking or baking, whatever, and you measure out some water in a measuring cup. What you might have noticed, you may not have noticed this yet, but be on the lookout for it from now on. It's pretty cool. What you'll notice is that there's a slight little dip in the actual liquid. It's not just ramrod straight across the cup. It's actually kind of dipped a little. That is due to surface tension. And that dip is what becomes important in our reading on the graduated cylinder. I'm going to draw a pitiful little graduated cylinder, but to show you what I'm talking about for that little dip in the liquid in the water and why it's important. Okay, so we have our cylinder shape. We have our base so that it doesn't roll off the table. We have a little lip at the top, and that's for pouring so that we don't get it everywhere when we pour. And then we have some markings, the graduated markings along the side. And let's say we pour some water into this. So we fill it up to a certain amount, and the water makes that concave dip. This dip is called a meniscus. Y'all need to know this term. This is actually used in, as we're describing an experiment, I might tell y'all, hey, measure it from the bottom of the meniscus. This is what I'm referring to, that little concave dip at the top. Again, this is due to the surface tension of water. It's a property it has. It's really important. But the way we read the graduated cylinder is affected by this meniscus. When you are reading the markings on the side of the graduated cylinder, so this tells you how many, for example, milliliters are in the graduated cylinder, you want to be eye level with the meniscus. So I'm going to draw that as this little kind of eyeball-y shape right here. You want to be, here's your eyeball, eye. You need to be eye level with the meniscus. A lot of the times this means you're actually squatting down at the lab bench to look at it. Let's look at a picture that shows why this is important. Again, in actual glassware, this is what you will see for that little meniscus of the water. It's not totally flat, it's a little concave, and that makes a difference. We'll go over how to specifically read these measurements in a moment, but for right now, I want to focus on why is it important for us to be eye level. All right, so here's another picture. We have that, like how that eyeball has eyelashes. So we want to be eye level with meniscus. Y'all, do not hold the graduated cylinder up to your eyes. Your hands are not that steady. Trust me. Keep it on a bench, a table, squat down to the level. Here is a picture. So the meniscus, so that concave shape, has been exaggerated a little bit, but it's for the example here. If you are standing above the meniscus and you try to take a reading, you are going to underestimate your volume. So see how this yellow line goes down, you underestimate. If you squat too far low and you look up, then you're going to overestimate. The correct way, eye level with the bottom of the meniscus. Bottom of the meniscus. Flat across, straight across that bottom. So how do we actually take a measurement on a graduated cylinder? Again, it's not as easy as the digital balance. That just spits out the number. But in this case, you actually need to estimate the number yourself. So let's go back to the paper and look at how this works. I also want to point out that I left a link to a YouTube video of someone else explaining this, of how to read graduated cylinders, because I recognize this is kind of a funky topic, especially since I don't have glassware to pass out to y'all to practice with. So if you want a different explanation style, look at that link. All right, I'm going to draw another cartoon graduated cylinder, but I'm going to give it a little bit more detail this time. So how to read graduated cylinders. Okay. It's actually pretty darn good. There are different sizes of graduated cylinders. The topmost marking on the graduated cylinder tells you its maximum volume. So the max it can measure out at one time. So at the top of the glassware, you'll either see the number printed at the tippy top in very big font, or it will be the topmost measurement. For example, let's say we are working with a 100 milliliter graduated cylinder. So we call it by the volume it can maximum measure out. So a 100 milliliter graduated cylinder can measure out 100 milliliters. So depending upon the brand, it will either say 100 milliliters at the tippy top in big font, or it will just have the top measurement. So the top measurement is the max. And again, we're going to have graduated markings, graduated cylinder, along the side that tell us how much liquid we have. So if I'm going to try to space the major tick lines equally apart. So let's do a transition. Voila, here is my beautiful graduated cylinder. These big marks are the major tick marks. So it's just like on a ruler, how you have like the big intervals. And then you're gonna have little markings between. And I'm just drawing an arbitrary number here, y'all, because I don't have enough room to fit in all the tick marks. But we see we have minor tick marks. This is just like reading a ruler. So let's say that, again, I pour some water into here, and let's say it fills up to here. So here's my meniscus. Again, here is the bottom. Ooh, that's not a straight line. The bottom of the meniscus. So you want your eyeball to be here to read it. How you read the number off the graduated cylinder goes like this. You find the major interval that you know the liquid is between. So in this case, it's between 60 and 70. So I know for a fact I have at least 60 mils of water. Then I look at the minor tick mark. So the minor tick mark interval does not always stay the same from one graduated cylinder to the next. Again, we have different sizes of this glassware. So the major and minor tick marks are going to change based on the size of the glassware. So we're going to look at some examples in a second where we can really make out the minor tick marks. But the overall process is the same. So you look at your major tick mark and you say, I have at least 60 mils. Then you look at your minor tick mark. You figure out what each minor tick mark corresponds to. Maybe it's 1 milliliter. Maybe it's 2 milliliters. You read the minor tick mark. So in this case, it looks approximately like I have at least 64 milliliters. So major tick mark, minor tick mark. And then you're going to make your best educated guess on one digit past the minor tick mark. So for example, maybe I think this looks like 64.2 milliliters. I know I have at least 60. I know I have at least 4 from the minor tick mark. And then I'm going to make my best educated guess of the level 1 point past that. Let's look at some cartoon examples, and then we will move on to real glassware. And y'all, I'm not expecting you to be experts at this. Like, it makes way more sense when you actually are working with the glassware itself. Alrighty, let's look at some cartoon examples. Again, it is a different kind of feeling when you're working with actual glassware, but we need to know the theory of it moving forward. Okay, so in letter A, we have 1 mil, 2 mils, and 3 mils for the major tick mark. So it's going up by 1 mil at a time. Y'all read this just like how you'd read a ruler. You look for the major interval. So here 1 mil. Then you look how many minor tick marks you have. And you ask yourself, okay, how do I spread that major interval across the minor tick marks? So in this case, so we start with 1 mil. So 1.2, 1.4, 1.6, 1.8, and then 2 mils. I know that the meniscus in this example, so again, we're looking at that flat part of the meniscus. I know that I have at least 2 mils because the water level is between 2 and 3. Now I need to figure out at which minor tick mark that meniscus lands or lands close to. So I have 2.2, 2.4, 2.6, and then this tick mark is 2.8. Sorry, y'all, I don't have a tablet, using my mouse. So I know I have at least 2.8 mils of liquid. Now I'm going to look at the meniscus and give this my most educated guess. This level doesn't quite look halfway between this tick mark and the 3 tick mark. I think it's a little bit lower than that. So I think this level is a little lower than 2.85. I think it's between 2.8 and 2.85. honestly, to me, this looks like 2.83. Ooh, it's bad. 2.83. So again, major tick mark, minor tick mark, and then our best educated guess, one place past that. Let's look at letter B now. So 8, 9, 10. Again, our major tick mark is going by 1 milliliter at a time. But in this example, I have a lot more minor tick marks between the major tick marks. So I'm going to be able to get more decimal places out of this answer. So let's start at the bottom. 8. So let's see how many minor tick marks there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the minor tick marks are going in intervals of 0.1 milliliters. Sorry, y'all. Again, I don't have a tablet. This is rough. Using my mouse. So I know that I have 8 mils. I know I at least have 9 mils because that meniscus is above the 9. But that meniscus is not quite at 9.1. So it's between 9 and 9.1. So I'm going to give my best educated guess here. This, to me, looks like, it's not quite halfway between. You know what? I'm going to go with 9. Sorry. that was a real bad one. I'm going to go with 9.04 mils for this one. So what I'm expecting you to see is definitely what major tick mark it passes and between which minor tick marks. So this is how you read it. Cartoons are much more straightforward to look at than real glassware. For example, again, this picture. That meniscus is kind of tough to see, right? Like this is 3D. But what I want you to see is that we have a meniscus approximately here that we would read from. Doing this on real glassware hits differently, so we're just going to have to practice that when we get to it. For now, know that this is how you read a graduated cylinder. So for this portion of the lecture video, pretend we're squatting down, which is actually what you'll have to do when you take real measurements. You normally have to squat down to eye level at the lab bench. Let's look at those values. So I have that little teeny tiny cylinder in my hands. I have my hand behind it so that we can read the white text. What we notice is that the top marking says 10 milliliters. This graduated cylinder can only measure out 10 milliliters at one time. But let's look at the little markings. What do the little markings mean? So the big tick marks are 1 milliliter tick marks, so 10 to 9 to 8 and so on. That means that the little tick marks between them must correspond to intervals between 9 and 10. So if we count, we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of those little teeny tiny tick marks corresponds to 1/10 of a milliliter. You can think of this as 0.1. Let's look at the slightly 10 times bigger one. So you notice this says 100 milliliters at the top, and also we see the marking for 100 milliliters. So this cylinder can measure out 100 milliliters at a time. The big tick marks are intervals of 10
milliliters, 100 to 90 to 80, so on. So what do the little tick marks correspond to then? Well, we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 little tick marks between here and here. So 10 little tick marks total. That means that each little tick mark corresponds to 1 milliliter. So for example, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. Let's look at the big graduated cylinder. So I have to hold the camera freehand because this is so big and out of frame. So this graduated cylinder can measure out 1,000 milliliters at a time. Milli means 1,000 or 1,000th. So that means this graduated cylinder can measure out 1 liter of liquid at a time. So let's look at the major tick marks. 1,000 to 900 to 800, 700, 600, 500. The big tick marks are in intervals of 100 milliliters. What we have here is a beaker full of water. So I labeled it, H2O is water. Always make sure you label everything you use. Here is our 100 milliliter graduated cylinder. Y'all, I am not expecting you to be able to perfectly read these measurements from a video I am filming. That is an unrealistic expectation, but I want you to see the process on a real piece of glassware. What I'm going to do is pour an unspecified amount of water into this graduated cylinder, and we are going to go through the process of obtaining a measurement. First, make sure that you are at eye level with the liquid. If you are too high or too far below, you will get inaccurate readings. Let's zoom in on this. So, this right here is the meniscus of the water. Water forms that concave shape due to surface tension. So to obtain an accurate reading, you want to look at the very bottom of the meniscus. Remember, when you are reading a graduated cylinder, you read at what major tick the liquid passes, what minor tick the liquid passes, and then you're going to give your best estimate of one digit below the minor tick mark. We know that this graduated cylinder, the major tick mark goes by tens. So we know that we have at least 50 milliliters because we're between 50 and 60. Then for the minor tick mark, so if we see here, let's zoom out a little bit so we can see where we are. Zoom in a little bit more, there we go. All right, so that meniscus is above 55, just above 56, and not quite at 57. So we know for certain there are 56 milliliters of water in this graduated cylinder. We know 56 at our minor tick mark, and now we're gonna give our best guess of the next digit. So we know 56, so 56 point what? So again, y'all, I'm not expecting you to be perfect on, a filmed graduated cylinder, but I want you to see the process. It's 56 point, that looks like a 0.1 to me. So 56.1. That is how you read a graduated cylinder.